An important example of a DNA virus is herpes simplex virus, or HSV, strains of which cause cold sores and genital herpes. The virion consists of a double-stranded DNA chromosome packed within an icosahedral capsid. The capsid is surrounded by about 15 different kinds of virus-encoded proteins, collectively called tegument. The tegument is contained within a host-derived membrane envelope with several kinds of spike proteins. The herpes virion can bind to several alternative receptor molecules in the host cell membrane, after which the envelope fuses with the host membrane, releasing the capsid into the cytoplasm. The capsid travels down a scaffold of microtubules to the nuclear membrane. At the same time, a protein from the tegument, called virion host shutoff, or VHS protein, degrades the host cell's mRNA molecules and thereby eliminates the competition for ribosomes and other cellular machinery. Another tegument protein called VP16 ultimately protects viral mRNAs. It also acts as a transcriptional activator of gene expression in the viral genome. At a nuclear pore, the herpes chromosome enters the nucleus. The DNA then circularizes to form a plasmid-like intermediate. VP16 works in concert with host factors to activate a set of viral genes called immediate early genes. These immediate early mRNAs leave the nucleus for the cytoplasm, where ribosomes translate them into proteins. In expressing these immediate early genes, the virus has entered a pathway called a lytic infection, in which a cascade of events culminates in the production of new virions. However, the virus could have entered a pathway called a latent infection, in which genes called latency or LAT genes are transcribed and keep the cell from committing suicide and from producing new virions. In a latent infection, the DNA circle can persist within the cell for decades before switching to a lytic infection. Latent infection most commonly occurs in nerve cells. In the lytic infection, the translated proteins of the immediate early genes return to the nucleus, where they turn on the expression of another set of genes called early genes. The mRNAs travel to the cytoplasm, where ribosomes translate them into proteins. These early proteins include a viral DNA polymerase. The DNA polymerase and other proteins replicate the circular viral DNA. The production of new genomes for progeny viruses occurs by the rolling circle method, which generates a concatemer of many copies of the viral DNA. The newly synthesized DNA expresses late-stage mRNA, which exits the nucleus for translation. Some of the mRNAs encode capsid proteins and are translated on free ribosomes in the cytoplasm. Some of the late mRNAs encode envelope proteins, which are translated on ribosomes on the endoplasmic reticulum. Many late-stage proteins re-enter the nucleus to form capsids, and these capsids capture DNA genomes. A capsid buds through the internuclear membrane, becoming enveloped by a single membrane. The developing virion moves through the endoplasmic reticulum and buds off, after which it fuses with the Golgi apparatus. The virion eventually buds off the Golgi apparatus and fuses with the plasma membrane. The completed virion is now outside the cell. The primary infection occurs in epithelial cells, followed by latent infection within neurons of ganglia near the original site of infection. How a latent, rather than lytic infection initiates in neurons is not well understood. The latent infection of the ganglia later leads to new outbreaks of virus, often triggered by stress, sunlight exposure, or depression of the immune system. Progeny virions travel back to the epithelia, causing lytic infection.